I think the first three talks here already have kind of set the stage on where we're going. So just to dive into it, I'm going to talk about the current conditions and the outlook going forward. Again, I'm going to focus mostly on Arizona, but some regional discussion. And then also going to do a really high altitude overview of what we're really doing with the drought monitor. So with that, so this is the map that came out this morning, just hot off the presses here a couple hours ago. We can still see that, you draw a line on the Rocky Mountains and look west of there. A good portion of the country is in significant drought still. Looking in the Southwest as a whole, definitely has improved from where we were a year ago, but still issues, and I'm going to dig into that a little bit more. So as we zoom into Arizona, we can see that, right now 77% of the state is in some level of drought. A year ago, we were at 100%. What we did see, the big change here is, right now we see no D4 in the state and only about 9% of the state in D3 or extreme drought. A year ago, that number was right at 93%. So even though drought is still lingering on, the intensity definitely has diminished. And just some visuals again here, where we're at on the right-hand side today, where we were a year ago. A year ago, most of Arizona was in D3 and D4. And when we look at those pie charts to the right, 77% of the state was in D4 a year ago, and add another 16% in D3. That took us to right at that 93% number, with 77% being in D4. So pretty exceptional drought was taking place. And, what we're seeing now with the drought situation in Arizona and the Southwest as a whole is, even with some of the improvements that we've seen, longevity starting to set in. That we're not looking at a flash drought or something that spins up for 1 year and kind of goes away. And it's been hinted on in the first talk from the State Climate Office is we've seen pretty much ongoing drought now for quite a while. We've had some wet periods intermixed in there, but definitely the dry periods have been the vast majority of the periods that we've seen. So it's not like we're completely out of the woods yet, even with some of the improvements that we've seen. And really, a lot of folks have been making some pretty tough decisions as far as resource management over the last several decades now of how things are going to be addressed. So just some quick numbers that I pulled up here. So precipitation in the month of July. Looking at this here, we can see that, some places in Arizona, 6 to 8 inches of precipitation where the monsoon was really kicking in. Some localized amounts were even greater than this. This is basically just the co-op stations and the ASOS stations as part of the Weather Service network. And then we look at August and continuation. So when you look at July and August as a whole, we definitely see that, especially in the southern deserts of Arizona and the Central Valley of Arizona, some significant rainfall taking place. And when we're talking about places that typically get less than 10 inches in a calendar year, when we start seeing some of these monthly amounts, it really becomes staggering. And then even into September, we kind of pushed it up a little bit further north, that this wetter pattern continued. Some of these places 4 to 5 inches of precipitation just in that month. And so when we start looking at the percent of normal precipitation on the left-hand side, we're seeing that through the months of July, August, and September, that southern half of the state really they were the winners. If there's winners and losers in drought, we can definitely say that during this period, that southern Arizona not only saw some near record or record-breaking precipitation for that 3-month period, but it was widespread too. And then we look at the percent of normal precipitation, looking at the 2021 water year, and you can see that again, pretty much southern Arizona, these numbers were greatly above normal. But the further north you got, again, those areas were missed out and became more spotty. And even on some of those areas that border New Mexico, it became a little bit more spotty, at least for the water year. And pulling up the West-wide drought tracker information that just came out this morning as well. I like this prism-based product to get some really high definition data for Arizona and the West as a whole. And as a Drought Monitor author, when I'm the author at the beginning of a month, when these numbers are updated, I actually pull these data into my GIS because I like that high resolution for precipitation, SPI, SPEI, et cetera. And so looking at these precipitation percentiles for January to November, so basically the calendar year of 21 on the left-hand side, you can see that, again, this pattern shows up well in those southern desert areas, even into central Arizona that were near normal. In the white, and the greens are above normal. The darker greens are much above normal. And when we start looking at the June through November precipitation percentiles on the right-hand side, again, really capturing when those improvements were taking place. The summer monsoon, after many previous summers being misses, in my opinion, as far as relief or even any kind of precipitation from the summer monsoon, this last year, not only was it a hit, but it was widespread too. It wasn't like we'd seen in some past years where maybe just some pockets of improvement or pockets of precipitation were associated with that monsoon event, but really was more widespread. And that's where we led to the improvements on the Drought Monitor. Again, we finally saw the physical indicators on both the short and long term starting to catch up a little bit. And we were able to show that improvement on the map, even though, and acknowledging that some of those longer term issues were still there and still present, and they're still with us right now. And we're going to have to really watch things as we go into the winter months. Looking at the 24-month SPEI, so this is going back 2 years now. And I think this really shows the difference between what I was showing on these two images, where we were seeing the short-term improvement, definitely through the summer months, even over the last year. But if we go back 2 years, the temperatures and precipitation definitely are showing that in Arizona, there's still concerns when you're talking about 1 to 2 deviations of below normal on the southern half of the state, and in the northern half of the state, even greater than 2.5 deviations. You're still talking some significant issues that are taking place. And what that means is a dry spell of a couple months. Again, winter's going to play a key part in this, but we could see degradation kind of rear its head quite quickly again, as some of these areas are still quite vulnerable. And as we look in the west, snow and snow water equivalency are key this time of year. We really want to see that, Arizona is really the only couple snowtail sites that are well above normal in the central part of the state, and the few areas of the state that do have snowtail sites. So that's encouraging. But the west as a whole, again, the snow hasn't showed up yet. Even in some of those upper elevation areas, these basins are not showing too much snowfall at all for this time of year. Again, this was just updated earlier this week as well. So what does that mean going forward? So we have two different drought outlooks I'm going to show. First is the monthly for December. Looking at the Southwest as a whole, the only areas of some degradation that are being shown on those areas in yellow where drought is going to likely develop is in West Texas and New Mexico. Again, definitely a La Nina pattern on a lot of these outlooks. Arizona going through the end of December, not really showing too much changes at all. But when we go out further for the entire winter season, taking us through the end of February, we see more of that La Nina signal, which is typically warmer and drier than normal in the southern tier of the U.S., wetter and cooler than normal in the Pacific Northwest and the upper Midwest. And so that's kind of how these outlooks are really showing that La Nina signal. It is a moderate La Nina for this year. And so it's not too surprising that our outlooks are kind of following that stronger ENSO signal through the winter months. So what does that mean through the end of February? We're probably going to see drought development and more of the Southwest. Again, looks like by the end of February, to say that the whole Southwest is again in drought is not going to be out of the realm. And we're really going to have to watch as the weather patterns set up. Typically by mid-December, the weather pattern has established itself and we'll know where those storm tracks are going. So kind of stay tuned to the next couple, 2-3 weeks to see where we end up with that weather pattern set up in this La Nina situation. So that was all I had on the recent or current conditions and the outlook. And I'll transition right in, Joel, to the high overview of the Drought Monitor production and what we're doing. And I'm assuming many on this call already are familiar with the Drought Monitor, so I'm not going to get too in the weeds on this, but Just want to acknowledge this is a partnership between the NDMC, NOAA, and USDA to get this out every week. It has been since late 1999 when it began as an experimental product and quickly went operational by the end of 1999. It's used in many USDA relief programs. The IRS is also using this in tax deferral programs as well. When there's drought, we get a lot of traffic to this site. 10 to 12 million hits on a normal year. When there's more drought, that number ramps up as well. Just to go back, droughtmonitor.unl in the upper right-hand corner of the slide is the website. And it's more than just the map. Go in and explore the different maps, the archives, the data, the GIS data. There's all sorts of information on those tabs above the top that we continue to share. And if there's something that you'd like to see on this website that isn't available and you'd like to see it, send me an email, give me a phone call, and I'd be glad to share my thoughts with the authors, and we can put that onto our schedule of different upgrades. So what do these drought categories mean? So we start looking at all the different indicators that go into the drought monitor. There's several dozen pieces of data that are being looked at, and we apply this percentiles methodology to each one of those indicators. So basically it's telling us how often or how rare these occurrences of the different drought intensities are available or have taken place. And so you can start off at D0 where the majority of the indicators are in that 21st to 30th percentile, all the way up to D4, where you're saying that when the majority of these indicators at a D4 level, that's only happened 1 or 2 times in 100 years of record. But what do we do when we have indicators that don't have 100 years of record or shorter periods of record? What we're able to do is we're able to apply these to any parameter, regardless of the period of record. What's nice about longer periods of records is it gives you more confidence of how often or how rare these events can actually be, because you've had a few more instances of these severe, extreme, and exceptional drought taking place. What's unique about how we're looking at this is you think of drought as a rare event to begin with. And then on the drought monitor, we're trying to categorize not only the drought events, but even the rarest of the rare events. And that's when you start getting out to that D3, D4, you're really on the tails of the distributions. And that's what we're trying to do. And period of record is important because, again, we can do this with satellite data that may only have a few years of data, but even for longer periods of record. And then we try to mash that all together onto a single map. And again, that's where the map is kind of unique, that it's not just focused on short-term or long-term, but we're trying to capture all these different types of drought on a single map. And the question comes up often, well, why not do different maps? And the policymakers and decision makers, the powers that be, so to speak, from the beginning, this idea was broached to them, and they said, no, we don't want to have confusion. We want to have a single map with both short and long-term drought identified on it, and all these different types of drought identified on that map as well. So we are looking at meteorological, agricultural, hydrological, socioeconomic, and ecological drought all on a single map. And so depending on your area of expertise or area of interest, you may be looking at this map and say, heck, hydrology is looking great in our region. Why are we showing drought? But there could be ecological, meteorological, or agricultural drought. And again, that's our challenge as Drought Monitor authors, is to put this all on a single map. And so when we start looking at what constitutes the different data that we're looking at to put together the Drought Monitor, again, precipitation and snowpack are huge, but we also are taking into account humidity, evapotranspiration, vegetation health, stream flow, lake and reservoir level, soil moisture, and groundwater, and even on different time scales. So some of these are updated every day, and we can get updates of, where did it rain yesterday? Things like the National Weather Service co-op sites feeding into ACES and things like CocoRa's. We can see quickly where these changes are happening and the amounts that are associated with them. And then we start looking at different time scales. And with that, we get out to annual and even further than annual time scales. And these, again, all feed into the Drought Monitor. That it's not just a single short-term or long-term period that we're looking at, but again, we're trying to incorporate all these. So short-term, right now in Arizona, short-term is really good, But when we start looking at those long terms, kind of that 2-year, 24-month SPEI map I threw up there, we can see that, oh, hey, yeah, long term, we're seeing issues. And that's where you see those labels on the map. The S is for short term, the L for long term, or SL for a combination of short and long term. And this came up earlier in the summer. One of our partners with the Weather Service out in Salt Lake City, Andrea Baer, she had a conversation with me, and she said, you know, what you're doing and the other authors are doing, it's really the drought machine. And we through our discussion, this came up a couple of times, and so I kind of came up with this slide that the authors, you know, we're the ones wrangling in all the data. And we focus on the data, the impacts, the feedback, the climate, and the validation. So each one of those blue boxes is important to the process, but by themselves, we could do a whole day's conversation on just the data. And today we're focusing on impacts or the feedback mechanisms or the climate of the region. You know, how's the climate changing, and what are we seeing over the last 2 or 3 decades that we haven't seen over the last 100 years? Then that validation too, you know, the boots on the ground, the discussion on the ground that validates the climate, the feedback, the impacts, and the data. All of that is part of this drought machine. And us authors, we try to wrangle it all in, try to lasso it all in. And you know what I say in the box on the left here is the map is the end product, but the process is what makes the Drought Monitor unique and what it is that we do incorporate the physical indices and indicators along with this feedback and impact and validation process that is unique to what we're doing. And I just say, trust that process. We work with many partners that are up here and others. There are too many logos to get everyone up here, but I do like this. This came out of the early 2000s. There was significant drought in my neck of the woods, and the moms telling their kids, don't be afraid, it's just called rain. And that was kind of in the middle of our drought. If you want to get in touch with me, email is probably the best way to do it right now, as I'm still working a hybrid schedule between home and the office, or leave me a voicemail message at my phone number listed there, and I'll get back in touch with you.